Okay, so the next one I want to put on here is this picture. That is called, okay, so on the front is the picture, remember. So on the front of your flashcard, you're making that picture. And then on the back, the name of it is the identity function. And its equation is y equals x. So we now have two flashcards made. The front has a graph. The back has the name and the equation. The next one I want you to do is this one. Nice squiggly little line. That's the front, remember. And on the back, you'll write the name. This is called the cubing function. And its equation is y equals x cubed. I want you to do, you've seen before because you studied it a lot in second year algebra, it's a V. And it is called the absolute value function. And its equation is y equals the absolute value of x. So remember, on the front goes the picture, the graph. On the back goes the equation and the name. Okay. Because I'm taping, I'm going to have to stay on this board, so I'm going to start erasing. Everybody got the first two anyway? All right, so here we go. There are 12 altogether. That's why you made 12 flashcards. Well, some of you made more, but we're only going to use 12 flashcards. So we got 4 of them done. All right, so here come the next two. This one, and I'm not doing these in any special order. I'm kind of doing them in the order I remember them. This picture is called the logarithmic function. And its equation is y equals ln x. You recognize the ln. That's an ln, not a 1n. That's your natural logarithm. And this is what it looks like. Now on this one, I'm going to be a little bit pickier than I have been. I want you to label this point 1, 0. I haven't had to label any points yet, although some of them have certainly gone through the origin, right? So you would know that point. But I want you to actually label the point 1, 0 on your graph. And then we have kind of the opposite of that one. It looks like this. See how they're kind of closely related, but kind of flips of each other? This is the point. You want to take a wild guess?
0, 1.
0, 1. Very good. That's the point 0, 1. This is your exponential function. And its equation is y equals e to the x.
Bless you.
E, in case you've forgotten, and you might have, E is a number just like pi. You know how pi goes on forever and ever and ever, never repeats or stops? Yes. So does E. E is called Euler's Euler's constant. It's spelled a little different than the Houston Oilers, but it's said the same way. Euler's constant. And it is approximately, you know how pi is approximately 3.14, E is approximately 2.718. It is the base of the exponential function. That's kind of extra information for you to know because you're smart mathematicians. Flashcard has this on the front, this on the back. All right, now we've got a picture that looks like this. This one is called the logistic function, and it's used a lot when we study populations, logistics, the logistic function. And its equation is y equals 1 over 1 plus e to the negative x. That's probably the toughest equation you have to memorize. It's a tough one. Squeeze one more in here. My least favorite is this function. Have you seen this before? It's called a step function, and I think it's clear to you why it's called a step function, right? Its equation, or its name, is the greatest integer function. This is the name of it, the greatest integer function. And its equation, I'm going to use this notation, the bracketed notation. Different books use different notations. So I'm just going with the one I learned first. But you might see it different.
So it's the greatest integer function, not the step function?
Yes. No, it's an example of a step function. This particular one is the greatest integer function. Good question. There are lots of step functions, actually. And then we've got, I'm putting a dashed line down my y-axis and a dashed line down my x-axis. Those are asymptotes for this next curve. It looks like this. So that's the picture you're going to draw. This is what we call the reciprocal function. Reciprocal function. And you'll see why. Its equation is y equals 1 over x. So the name makes sense, doesn't it? Y equals 1 over x. Now we're going to do the sine function. So the name is the sine function. The equation is y equals sine x. We're going to look at this, some of us are, and say sin. That's gonna sound silly in math class. It's sine. This is the sine function. It's y equals sine x. And then we have our cosine function on another note card. And it will be y equals cosine x, cos x.
You draw anything on that?
We're gonna draw a picture. Yep, I'm kind of delaying that because I'm gonna need your full attention when we draft this. Okay, you're not gonna understand these labels, and it's perfectly okay at this point. You need to know the labels, you need to be able to graph it, but as we study our trigonometry, this will make more sense. On your y-axis, I want you to go from -1 to 1. Have both these cards laying there, so we're doing kind of gonna do them together. We're gonna draw these pictures together. So both of them, we're going to -1 to 1. On our x-axis, I need you to make 4 hash marks on both of them. These two pictures are going to look a lot alike. Everybody keeping up? All right, now the labels. On the x's, here, now we're going to label these, and they're going to be labeled exactly the same way. This first one right here, look where I am, is pi over 2. Now again, I don't expect you to understand that right now. You haven't been taught it. Just take my word for it. It's pi over 2. It will make sense as we move through the year. The next one is pi. The next one's 3 pi over 2, and the last one is 2 pi. This is like a number line, so it's exactly reversed over here. So negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So here's 0. I got the positive ones going that way and the negative ones going that way. Now as soon as you're done with the sine card, I want you to come over and do exactly the same thing with your cosine card. Label it exactly the same way. The pictures are going to look slightly different, but the setup is exactly the same. Okay, so are we all set? Everybody got your labels done? All right, here's the curve. I want you to put a dot right here at the origin. We're on our sine. This is our sine card. Make sure you're on the right card. You're on the sine card. And you put a dot right here. And then you put a dot up here. Look at where I'm putting my dots. You put them in the same place. And then connect them with a nice, smooth curve. And then go the opposite direction. That is a picture of your sine curve. So put your dots where I did. Make sure your dots are in the right spot, because this is the curve you're going to study, so you want it to look just like mine. Everybody got it? And and then we're gonna do our cosine. Now the cosine's gonna have those hills and valleys, but here's the difference. First dot goes up here. Remember when you did your sine, you put your first dot here? Your first dot goes up here, and then you have dots just like before. So here are your hills and valleys, just like before, but it's positioned differently. You okay? That's your sine and your cosine. Now, I'm going to tell you something kind of goofy. Use it or not use it. I can tell maybe some of you are a little like, okay, I know if it's got hills and valleys, it's a sine or a cosine, but how am I going to keep these two straight? Well, 36 years teaching math in a Catholic school, I think of original sin. Origin, sine. The sine curve goes through the origin.
It's a bar.
The cosine does not.
That's a bar.
Somehow you gotta keep it straight, because this board's gonna give a quiz at some point, and the quiz is gonna say, what curve is this? And you're gonna look at it and you're gonna say, okay, I know it's a sine or a cosine, and you're gonna have to decide which one it is by noticing it doesn't go through the origin. Therefore, it must be a cosine.
I think it helps if you like say like the W is cosine and the M is sine.
Yeah,
Okay?
that's what I thought.
W's and M's. Whatever works. Whatever works. Alright, that should be 11. You should have one card left.
Yeah.
And the last function is this one. Yeah, I'm sorry, I should have given you the picture first. I don't know what I'm doing. I need the picture, sorry. Here's the picture. There's the picture, just that little thing. It's called the square root function. Obviously, when you look at the equation, you know the name of it's going to be the square root function. Okay? Next time we meet, I'll have an example of a quiz. I'll just run off a quiz I gave maybe last year. And then the time after that, we're going to have a real quiz. So you need to start getting these memorized, because we've got other stuff we have to do. So everybody got these down? Put your note cards in a safe place so we don't lose them. Everybody understands you need to know the picture, the name, and the equation. So I might say to you on a quiz, sketch y equals ln x. You have to know what shape goes with the logarithmic function. So you would sketch this and label the point 1, 0, because that's what I had you do on your note card. All right? So you got time, start studying those. If you're laying by the pool this weekend, or you're driving somewhere, take your flashcards.
While driving?
No. I assumed your parents would be driving and you'd be riding along. No. I want you to do math all the time, but not while you're driving. We're going to go to the bathroom and we're going to go to lunch in like a few minutes. Can you just hang on? Okay. Yeah, we're going to go to lunch in about 4 minutes. All right, that gives us time to do one problem. Get your note sheets out. People act like the day is over. Come on, we have work to do. On your note sheets, this is your new packet. It says page 8. Because you've taken that many pages of notes so far this year.
C.
We're ready for C. And as soon as we're done with C, you can go to lunch. Okay? So here we go. With problem C on the front of your note sheets. Page 8, your new note sheets. We're doing problem C. We did the other two the other day. X minus 4 equals 5. Your job is to solve this equation without a calculator. Okay?
X squared minus 4.
So first thing I'm hearing is we need to do a little distribute.
Subtract 5.
Now, okay, now I've heard two things. I heard somebody say take out an X.
Oh, wait, we just.
Whoa, wait a minute. That would just take us right back to the beginning, right? Don't think I want to do that. Somebody else said subtract 5. I love that idea because what kind of an equation is this?
Quadratic.
Quadratic. And I want my quadratic equations to be set equal to 0. Now, some of you have already decided you're going to factor this one. It is easy to factor, no complications. If you don't want to factor it, you don't have to factor it. What could you do instead?
Quadratic.
Quadratic formula. It does factor very, very easily. How?
X minus 5. X
Minus
plus 1.
5 plus 1, which means that my answers would be x equals 5 or x equals negative 1. Do I draw a number line and do all that crazy shading? No. I only do that. I only do that when I have an inequality symbol. Okay? All right, quickly quadratic formula for those of you that did it that way, and then you can get up and go, okay? So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A is 1, b is negative 4, c is negative 5. Notice the double negative, that's going to give me a plus. 4 plus or minus the square root of 36. The square root of 36 is 6. 4 plus 6, 10. Divided by 2, 5. 4 minus 6, negative 2. Divided by 2, negative 1. Same answers, of course. All right, wait. I will see you back here in your seats at 12:20. Anybody not in the seat at 12:20 is going to bring me a box of Kleenex. Go. Well, if I am in here, the door will be open. If I'm not, I'll shut it. You don't have to take your stuff. I'll shut it and it locks.